Welcome back to the Deep Dive. We are back with another stack of research, and today we are looking at something that is simultaneously the most boring and maybe the most fascinating string of characters on the entire internet.
It is certainly the most ubiquitous, I'll give you that.
Absolutely.
Yeah.
We are talking about the very first line of code on essentially every single web page you have ever visited.
Yeah.
You right-click, you hit View Source, and before you get to the content, before the scripts, before any of the styles, there's this declaration. Usually it's just DOCTYPE HTML.
The document type declaration.
Right. And, looking through the materials we have today, the specs, the history, the browser notes, I was just struck by this central paradox. We talk all the time about code efficiency.
Right.
We talk about minification, compressing images, shaving off every possible millisecond of load time.
Oh, yeah. Every byte counts.
Every byte counts. And yet the entire web is built on shipping this one specific tag that, according to the modern spec itself, is mostly useless but required.
Yeah. It's a wonderful contradiction, isn't it? I mean, it really frames the whole discussion perfectly.
It does.
We are essentially shipping billions of bytes of data across the globe every single day that technically do nothing, at least not in terms of processing content. But if you take them away,
the whole thing falls apart.
the visual web just completely falls apart.
And that's what I want to get to the bottom of today. Because usually in engineering, if something is useless, you deprecate it. You get rid of it. You delete it.
Of course.
But here, we're keeping it. It feels, I don't know, it feels like a ritual. It's like we're lighting a candle before we start coding just to appease the gods of the internet or something.
Oh, that's surprisingly close to the truth, actually. The DOCTYPE is a fossil.
A fossil.
It's a remnant of a completely different era of computing history, the SGML era, that has survived into the modern web purely as a switch. It's just a signaling mechanism.
Okay, so the mission for this deep dive is to figure out why. We're going to unpack the syntax, which I learned is actually way, way more complex than just that simple HTML5 tag. We're going to look at the history of sniffing, which, I have to say, sounds a little illicit, but it's actually just browser logic.
And we have to talk about Quirks Mode.
We are definitely going to talk about Quirks Mode. And I really want to understand why modern browsers have decided to just completely ignore the sophisticated maps that were provided in the older code.
It's a journey. It's a journey from the very strict academic world of standardized markup to the messy, pragmatic reality of the web we actually built.
Okay, let's start at the beginning then. Section 1. What is a DOCTYPE? If we strip away all the modern context and just look at the definition in the source material, what are we actually looking at here?
To understand the DOCTYPE, you really have to understand that the web wasn't invented in a vacuum. It was born out of this whole world of document processing that already existed.
Right.
Specifically, it came from something called SGML, the Standard Generalized Markup Language.
SGML. This is like the grandfather of HTML, right?
Correct. SGML was a massive, incredibly complex international standard for defining document structures. It wasn't really a language itself, it was a meta language.
What does that mean, a meta language?
It was a language for creating other languages. And in that world, you couldn't just write tags willy-nilly. You couldn't just make things up. You had to define your terms first.
So you couldn't just invent a pizza tag unless you had first defined what a pizza tag was and what it could contain.
Exactly. You needed a rule book. And that rule book is called the document type definition.
The DTD.
The DTD is a file that says, okay, in this language, we have an element called pizza. It can contain cheese and sauce, but it absolutely cannot contain rocks. It lays out the entire grammar.
Okay, so the DTD is the law.
The DTD is the law, and the document type declaration is the instruction inside your actual document that links it to that law.
Ah, I see.
It's a way of telling the computer, hey, I'm about to send you some data. Before you try to read it, please go refer to this specific rulebook so you know how to interpret everything.
It's like declaring the rules of the game before you deal the cards. We're playing poker, so use the poker rulebook.
Precisely. And in the serialized form, which just means the actual text file you send over the wire, this instruction has to come first. It has to be right at the top.
Which is why we see it as that short string of markup at the very top of the file. Now, one thing the notes highlight is this concept of the root element. The DOCTYPE doesn't just point to a file, it also defines the root. What's that about?
This is a really critical parse-one concept. In SGML and its descendant, XML, a document is a tree structure.
Right, like a family tree.
Exactly. And every tree has to have a single trunk from which everything else branches off. The parser, the program reading the file, needs to know what that trunk is before it starts so it knows where to begin building the tree.
So for a web page, that root is almost always HTML.
Usually, yes. But in the abstract world of HTML, it could be anything. You could have a DOCTYPE where the root element is library or memo. But for the web, the DOCTYPE effectively says two things. I am declaring that this document adheres to the HTML DTD, and the root element of this tree is HTML.
So it's telling the parser, okay, get ready, expect an HTML tag to start this whole thing off.
Exactly. And this is important. The DOCTYPE then applies those rules to everything descending from that root.
The whole tree.
The entire tree. Once you declare the root, every single branch and leaf inside it is subject to the rules of that DTD you referenced.
Okay, so that's the theory. In a perfect world, or at least, in the academic world of the 1990s, the browser would see this DOCTYPE, it would go look up the rules in the DTD, and then it would validate your code against those rules. And if you broke a rule, the computer would throw an error and say, nope, not valid.
That was the dream of something called prescriptive markup. The idea was that if we all enforced these really strict rules, machines could easily read any document without any ambiguity.
But we know the web's not unambiguous. The web is a complete mess.
The web is a beautiful, beautiful mess.
So let's move to section 2 then, the browser's secret decision. Because this is really where the theory just collides head-on with reality.
Right. This is where it gets interesting.
So I asked myself this question when I was reading the notes. What happens if I mess this up? Let's say I'm a web developer in 1999. I forget the DOCTYPE or make a typo in it. Does the browser just stop working, crash?
Well, if the browser stopped working every time a developer made a typo, the internet would have died in 1996.
Fair point.
The browser makers, Netscape and Microsoft, in the thick of the browser wars, they faced this huge dilemma. They wanted to implement new standards. They wanted to support CSS correctly. They wanted to fix all the bugs in their rendering engines.
Sure, I wanted to move forward.
But millions of websites had already been built, and they were built relying on the old, buggy behavior. If they just fixed the browser, all those old sites would shatter. Layouts would break. Text would overlap everywhere. It would have been a complete disaster. The web would have become unusable overnight.
So they couldn't just update the engine. They had to somehow support the bad code and the good code at the same time.
Enter DOCTYPE sniffing and switching.
Sniffing. It sounds so investigative, like a detective.
It is, in a way. When a browser receives a document that's served as text-HTML, it doesn't just blindly start rendering it. It looks at that very first line, the DOCTYPE, and it sniffs it.
Sniffs it.
It checks it against an internal list of known patterns to decide which rendering mode it should use. It's making a judgment call based on that one line.
And this is where we get the two main modes, right?
Right.
Quirks Mode and Standards Mode.
There's actually a third one called Almost Standards Mode, which is a whole other rabbit hole. But yeah, let's stick to the big two for clarity. They're the most important.
Okay, let's talk about Quirks Mode. The name itself implies it's just a little bit weird, but the source material suggests it's actually a highly sophisticated emulation of failure.
That is a great way to put it. Quirks Mode is a compatibility layer. If the DOCTYPE is missing entirely, or if it's an old, malformed DOCTYPE that suggests the author didn't know about modern standards.
So if it looks like it was written in 1998.
Exactly. The browser enters Quirks Mode, and in this mode, the browser deliberately, intentionally violates the modern web specifications to mimic the behavior of old browsers, like Internet Explorer 5 or Netscape 4.
Can we get specific here? The notes mention something called the box model. This seems to be the biggest, most famous difference between the modes.
This is the classic example. It's the one everyone points to. So imagine you have a box on your screen, a div, let's say.
Okay.
And you write some CSS. You say its width is 100 pixels, and you add 10 pixels of padding on each side.
All right, 100 pixels wide, 10 pixels of padding. Got it.
In the W3C standards, the correct way, which is what standards mode uses, the width property refers only to the content area.
Okay.
So you have 100 pixels of content plus 10 pixels of padding on the left plus 10 pixels of padding on the right. What's the total visible width of the box?
120 pixels. 100 plus 10 plus 10.
Correct. That makes logical sense. That's standards mode. But in the old Internet Explorer, they did it differently.
How so?
They said, if I declare the width as 100, the whole darn box should be 100 pixels wide, period. So they squished the content. The padding was included inside that 100 pixel width. The content area would only be 80 pixels.
Oh, I see. So if I built a whole website relying on my boxes being exactly 100 pixels wide to fit next to each other, and then suddenly the browser updates and starts following the standard.
Your box is now 120 pixels wide.
And my entire layout breaks. My sidebar probably falls down to the bottom of the page. The whole site looks ruined.
And your boss is yelling at you. So Quirks Mode tells the modern browser, even the latest version of Chrome or Firefox running today, to use that old mathematically incorrect calculation for width.
It preserves the quark.
Exactly. But if you provide a correct modern DOCTYPE, the browser says, aha, this author knows what they're doing, they want to follow the specs. And it switches to standards mode using the correct box model.
So the DOCTYPE really is just a switch. But
Yeah.
here's the dirty secret that really blew my mind in the research.
Yeah.
We talked about how the DOCTYPE is supposed to point to a DTD file, right? A URL.
Yes, that's the theory.
So logic would suggest the browser would, download that file from the URL to check the rules. But the sources say that modern browsers have these special purpose HTML parsers that do not use general purpose DTD logic at all.
This is the big twist. Modern browsers, Chrome, Safari, Edge, Firefox, do not download the DTD.
They never look at the file.
Never. If you put a URL in your DOCTYPE pointing to, http://www.w3.org, something.dtd, the browser completely ignores that URL. It does not make a network request. It does not fetch it. It does not read it.
So why is it even there?
In the modern context, it is there purely for the string matching algorithm. That's it. The browser has a hard-coded internal list of strings.
The list of pattern.
Exactly. It just says, if the characters at the very top of this file match this specific sequence, turn on standards mode. If they don't, or if there's nothing there, turn on Quirks mode.
So it's not reading the map. It's just checking to see if you have a map in your hand.
That's a great way to put it. It's pure pattern recognition. The browser developers essentially said, parsing DTDs is slow, it's complex, and it's completely unnecessary because we already know what HTML is. They just baked the rules for HTML directly into the browser's C++ or Rust code, rather than having to read them from some external text file every time.
That is fascinating. It really means that DOCTYPE is strictly a trigger. It's not data. It's just a button.
It's a button disguised as data.
So if we're just poking a button, let's look at what that button actually looked like. Because before HTML5 came along, we weren't just typing HTML. We were typing these massive, complex incantations.
Oh, the syntax was a beast. It was something else.
Let's move to section 3 then. Anatomy of the syntax. I really want to deep dive into those characters because I feel like I typed them for 10 years without ever actually reading or understanding them.
All right, let's decode the cipher.
Okay, looking at the source here. The general syntax for a DOCTYPE in the old HTML style. It opens with DOCTYPE. I want to note the exclamation point. It feels like it's shouting.
It's a declaration. In markup languages, that exclamation point usually signals, hey, this is an instruction for the parser. This is not an element to be displayed on the page.
Okay, that makes sense. Then we have the root element, which we've established is usually HTML.
Right.
But then we get these keywords, public or system, and then these really long strings in quotes. Let's break down system first, because that one seems a little simpler.
System is the straightforward one. If you see the keyword system, it is followed by what's called a system identifier. In the context of XML and the web, this is almost always a URI, a uniform resource identifier, basically a URL.
So system just means, hey, browser, the rules, the DTD, it's located at this specific address, go get them.
Exactly. It points directly to a file on a disk or on a server. Very literal.
But we rarely use system on its own, did we? We almost always use public. What does public mean in this context?
Public is a bit more abstract. It indicates that the DTD is a public text.
A public text.
Yeah, it means this isn't just some random file on my personal server. This is a shared, well-known standard that should be known to the system already.
So it's like a celebrity file.
In a way, yeah. It points to a public identifier. This is just a unique name for that standard. It's kind of like saying the U.S. Constitution. You don't need to tell me the physical address of the piece of paper in the National Archives. The name itself identifies the document.
And this leads to that really specific weird string we always saw. The FPI, the formal public identifier. I want to parse this string. Natchez W3CTD XHTML 1.1EN. I used to stare at those slashes and just wonder what they meant.
It looks like total nonsense, but it's actually a very strict, very formal cataloging syntax.
Okay, let's break it down. What is the minus sign at the very beginning?
So that minus sign indicates the registration status of the identifier. A plus sign plus would mean it's an officially registered ISO standard. A minus sign means it is unregistered.
Wait, hold on a second. The standard for the World Wide Web from the W3C is marked as unregistered.
In the very strict formal sense of ISO SGML registration, yes. It basically just means we are an important organization, but we are not the International Organization for Standardization, ISO. So it starts with a minus.
That is a fantastic piece of trivia. The entire web is built on unregistered documents.
Pretty much. Then you have the /R, that's just the delimiter, a separator. Then W3C, that part is the owner identifier. It tells you who maintains this public text.
Okay, that makes sense. W3C, the World Wide Web Consortium.
Then another delimiter, and DTD XHTML 1.1. That is the public text class and the description. It tells you what kind of document it is, a DTD, and which version it is, XHTML 1.1.
And finally, the EN at the end.
That's the language, English.
So it's like a Dewey Decimal System for code. It's saying unregistered, owned by W3C. It's a DTD for XHTML 1.1, and it's in English.
Exactly. And the original idea was that a parser would have a catalog, like a lookup table, built right into it. It would see the string, look it up in its internal table, and the table would say, oh, I have a local copy of that DTD right here on the hard drive. I don't need to go out to the internet to find it.
But also, looking at the old syntax, right after that long public identifier string, there was also a URL in quotes. Why both?
That's the fallback. That's the backup plan. If you use public, you provide the official name, but just in case the parser doesn't have that name in its catalog, you also provide the system identifier, the URL, as a backup.
So it's like saying, here's the name of the book I want. If you don't have it in stock, here is the address of the library where you can go find it.
That's a perfect analogy. And in XML, this was very strict. If you used public, you had to provide the system identifier, URI, as well. You couldn't just leave it hanging.
Now, there's one more part of this syntax that the source material calls a hidden feature. The internal subset, the part with the square brackets.
Ah, yes. This is the part that the power users really loved.
Where does this even go? I don't think I've ever seen it.
It goes at the very end of the DOCTYPE declaration, just before the final closing angle bracket.
And what goes inside those brackets?
Actual DPD rules. You could define entities or even change element rules in line, right there inside your HTML file.
So I could, in theory, rewrite the rules of HTML from within the document itself.
To an extent, yes. The internal subset is processed first. It has the highest precedence. So if you defined an entity inside those brackets, it would override whatever was defined in the external DTD file.
Can you give me an example? I mean, why would I ever use this?
Well, back in the old days, you might use it to define a shortcut. For instance, you could define an entity called nleg to mean written by the legal department. Copyright 1999. Then, anywhere in your document where you typed nleg, the parser would automatically expand it to that full phrase.
It was like a variable, a macro.
Exactly. Or you could use it to temporarily disable certain validation rules if you were testing something or had a special case. It was very powerful in the proper SGML world.
But again, let me bring it back to modern browsers.
You know the answer. Chrome ignores it. Firefox ignores it. The browser's HTML parser is not a real SGML parser. It doesn't process entities defined in the internal subset. It just sees the brackets and skips right over them.
It's a vestigial organ. It's like the appendix of the syntax.
That's exactly what it is. It's there because the grammar says it's allowed to be there, but functionally, for the purpose of rendering a web page, it does absolutely nothing.
Okay, so we've got the syntax. Now let's look at the flavors. Because this wasn't just about syntax. It was about, I don't know, philosophy. In the HTML 4.01 era, we had to make a choice every single time we started a new file.
The clan wars. The DTD wars.
Section 4, the flavors of HTML. The notes list 3 really distinct DTDs for HTML 4.01.
Strict, transitional, and frame set.
Let's talk about strict. This one always felt like it was on the moral high ground.
It absolutely was. HTML 4.01 strict was the W3C basically saying this is how the web should be. The key characteristic of the strict DTD is that it did not allow any presentational markup.
And presentational markup means things that control how the page looks rather than what the content means.
Right. No font tags, no center tags, no BG color attributes on your table cells. The argument was all about separation of concerns. HTML is for structure and semantics. CSS is for presentation.
Which is, I mean, that's the standard best practice we all follow today.
It is now. But back then, CSS support in browsers was spotty, to be generous.
Right.
Internet Explorer 4 and Netscape 4 were just terrible at CSS. So if you were brave and used the strict DTD, you were often fighting against the browser to get even basic layouts to look right. It was a real pain.
So they gave us an out. They gave us the transitional DTD.
Also known as loose. The transitional DTD was a diplomatic compromise. It was the W3C saying, okay, we really want you to use CSS, but we acknowledge that you probably still need to use a font tag here and there or an align center attribute just to get this page to work for your client.
So it was the, we know you're trying, but we accept your flaws. DTD.
It was the bridge from the old way to the new way. It allowed all those deprecated presentational elements. And interestingly, almost everyone used transitional. It became the de facto standard because strict was just too painful for real-world production websites at the time.
And the third one, very quickly, frame set.
Ah, frames. A dark time.
For our younger listeners, can we just briefly explain what a frame even was?
Sure. Before we had good server-side includes or modern JavaScript frameworks, if you wanted a navigation bar that didn't reload every time you clicked a link, you used frames. You would essentially split the browser window itself into independent sub-windows.
Like a grid of little browser windows.
Exactly. One window for the menu, one for the header, one for the main content. But it was a usability nightmare.
Oh, it was terrible.
It completely broke the URL bar. The address in the browser wouldn't change as you navigated inside the frames. It broke bookmarking. It broke the back button. But if you used it, you needed a special DTD, the frameset DTD, which basically told the browser, hey, this page doesn't have a body tag. It has a frameset tag instead.
Okay, so that was HTML 4.01. But then came the era of XHTML, the X standing for XML.
This was the absolute peak of the strict philosophy. The W3C decided that HTML is just too messy, too forgiving. They wanted to reformulate HTML as a proper XML application.
Which meant it had to follow all the strict syntax rules of XML.
All of them. Case sensitivity became a big deal. In regular HTML, tag and tag are the same thing. In XML, they are completely different.
And XML requires lowercase tags.
Right. And you must close every single tag node, leaving a P tag open just because you started a new one. You have to write PP, and you have to put quotes around all your attribute values. No more with 100. It has to be with 100.
And the DTDs for XHTML, they just mirrored the HTML one.
For XHTML 1.0, yes. You had XHTML 1.0 strict, transitional, and frameset. But because it was XML, the syntax requirements were even tighter. For example, as we mentioned earlier, you had to include the system identifier, the URL, and the DOCTYPE. No inferring allowed.
And then came XHTML 1.1, the final form.
This was supposed to be the finalized revision. It was the purest form. It dropped the transitional and frameset options entirely. It was strict or nothing. It was designed to be modular. It was beautiful from a pure computer science perspective.
And it was a complete disaster in reality.
It failed spectacularly because of something called draconian error handling, which is a core principle of XML.
Draconian error handling.
Yes. In true XML, if you have a single syntax error, a missing quote, an unclosed tag, anything, the parser is required to stop. It's supposed to show an error message.
The yellow screen of death.
The famous yellow screen of death in Firefox, it doesn't try to guess what you meant. It just stops and refuses to render the page at all.
And you just can't have a web where a single missing quotation mark takes down the entire New York Times homepage.
Exactly. The robustness principle. Be conservative in what you send. Be liberal in what you accept. That's what won out. Browsers continued to accept messy HTML, and the strict XHTML revolution largely happened in name only. Most developers who thought they were writing XHTML were actually serving it as text-HTML, so the browsers were just treating it as tag soup anyway.
Which brings us finally to the resolution of our story, the great pragmatism of HTML5.
Section 5, the simplification.
We went from these massive intimidating strings, doc.headed HTML public, doc.headed W3C, DT HTML 1.0 transitional, and http.www.w3.org. I have to assume that in HTML5 we just simplified the DTD.
We didn't just simplify it, we obliterated the entire concept of the DTD.
So what is the modern syntax?
It's DOCTYPE HTML.
What's it?
That's the whole thing. Case-insensitive usually, no URL, no public identifier, no FPI, nothing.
Why? Why is it so short?
Because HTML5 is not defined by SGML, it's its own standard with its own parsing rules. It doesn't need to reference an external rulebook because the rules are defined in the HTML spec itself, which the browsers then implement natively in their code.
So it's an independent language now. It's all grown up and left home.
Correct. But here's the kicker. The spec still says the doc.html is required.
So why is it required if it doesn't even point to a DTD anymore?
Solely for the switch. The only reason DOCTYPE HTML exists is to satisfy that sniffing algorithm we talked about back in Section 2.
So it's just to trigger standards mode.
That is its one and only purpose. It is the shortest possible string of characters that triggers standards mode in Internet Explorer 6 and all of its successors.
It's a password.
It's the minimum viable DOCTYPE. The browser developers basically got together and asked, what is the absolute least amount of text we can force developers to type that will still convince our old legacy code that this is a modern page? And the answer was DOCTYPE HTML.
That is hilarious. It's like wearing a tie to a Zoom meeting, but you're still wearing pajama pants just out of frame.
Yeah.
You just need to show the tie, the DOCTYPE, to get into the meeting, which is standards mode.
That is a perfect description of what's happening. It looks like an old SGML declaration. It has the exclamation point, it has the DOCTYPE word, but it's completely hollow. There's no DTD behind it. It's a facade for legacy compatibility.
Now, you mentioned case sensitivity. In HTML5, it's insensitive, so I can write DOCTYPE in all lowercase, and it's fine.
In a regular HTML document served as text.tml, yes. But if you are writing XHTML5, which is the XML serialization of HTML5, then you are back in XML land.
And the strict rules apply again.
They do. XML is case sensitive. The root element HTML must be lowercase. Therefore, the DOCTYPE declaration must match that. You have to write DOCTYPE HTML, all lowercase.
And the notes also mention that in XHTML5, the DOCTYPE is actually optional.
Theoretically, yes. Because a true XML parser doesn't have a Quirks mode in the same way an HTML parser does, so it doesn't need the switch. However, the source mentions an important edge case, polyglot document, a document that's written to be valid as both HTML and XML simultaneously. If you want your file to be readable by a strict XML parser and render correctly in a regular web browser as HTML, you absolutely need the DOCTYPE to keep the browser in standards mode.
So, just keep it in.
Just keep it in. It's 15 characters. It saves you a potential world of pain.
It really is a fascinating evolution when you lay it all out.
Yeah.
We started with this incredibly high-minded, academic structure, public catalogs, system identifiers, internal subsets. We literally built a bureaucracy of code.
And then the messy market realities of the browser wars just came in and smashed that bureaucracy to pieces.
And what we're left with today is a fossil, a tiny 15-character scar at the top of every single file that just reminds us of this massive battle between purism and pragmatism.
And it's the ultimate victory of pragmatism. The standard now officially admits that the DOCTYPE is mostly useless. I mean, that's a refreshing level of honesty for a technical specification.
So to summarize our investigation today, we learned that the DOCTYPE is technically an instruction to associate a document with a DTD. But in reality, for modern web pages, it is just a behavioral trigger.
And we learned that sniffing is the browser's way of deciding whether it should emulate the bugs of the 1990s, which is Quirks Mode, or follow the rules of today, which is standards mode.
We learned that the URL in all those old DOCTYPEs was essentially a lie, or at least a suggestion that was universally ignored by the actual browsers who rely on internal pattern matching instead.
And we decoded the entire bureaucracy of the FPI, the owner, the class, the language, only to realize that the modern web has thrown all of it away for the simple, elegant DOCTYPE HTML.
It's just a great lesson in how standards actually evolve in the real world. They don't move in these perfect straight lines, they meander, they break, and sometimes they just leave these weird little artifacts behind.
It reminds us that code is written by humans for systems that have a history. We can't just delete the past. We have to build these compatibility layers on top of it forever.
Which leads me to a final thought I want to leave with you, the listener.
Let's hear it.
We've established that the modern web is built on a polite fiction. We include a line of code that looks like a definition, but it's actually just a trigger. The browser ignores the data and just looks at the shape of the tag.
Yes, that's right.
So if the Dockerancy type, the very first line of the web, is essentially a ritual we perform purely to appease legacy code from the days of Internet Explorer 6, what else are we doing?
That is the question.
How many other best practices that we follow in our modern stacks, in JavaScript, in our CSS, in our server configurations, are actually just rituals, things we do because that's how it's always been done, or because it used to fix a bug in a browser from 2015 that doesn't even exist anymore?
We're basically coding by superstition. We're afraid to remove the talisman because we don't remember exactly what demon it was originally designed to keep away.
The DOCTYPE is the ultimate talisman. And as long as browsers have that Quirks mode lurking inside them, we have to keep wearing it.
And honestly, considering the alternative is broken layouts everywhere and the return of the box model hack, I am more than happy to type those 15 characters.
Me too. Long live the DOCTYPE. Thank you for joining us on this deep dive into the invisible history of the web.
Always a pleasure to debug the past with you.
Check your source code, everyone. We'll see you on the next deep dive.